Hello, fellow chemists. In this video, we're going to take a look at rates of reaction. This is labeled as a basic level video because there's really no background information that you need to know to understand what I'm going to be talking about. So what is a rate of reaction? You can think of the word rate as speed, how fast the reaction occurs. So let's say you have a hypothetical reaction where you have molecule A and what it adds together with molecule B, they combine to form this new substance here. Well, the rate is simply how fast or how long it takes for this reaction to occur. And there's three things that affect the speed or the rate of a reaction. So let's imagine that we have a beaker, and in that beaker we have some solution, some water in it. And molecule A and molecule B are dissolved in the solution. They're really not these big green and red things floating around. They're tiny molecules dissolved in solution. But as they're floating around in solution, there's three things that kind of determine how fast and if they will react. Now, if you will, think of molecule A and molecule B as two different Lego pieces. Now, if you have Lego pieces, you have to fit them together. And not only do you have to fit them together, but you have to push them together with a certain amount of force for them to combine. Well, it's kind of the same thing with molecules when they're reacting. So the first thing that needs to be true for a reaction to occur is the molecules have to come in contact with each other. So they're floating around in solution, but they're just randomly moving around, bouncing off the walls. And every now and then, they will hit each other. And every time they hit each other, there's a chance that they will react. The second condition that needs to be true is after they hit each other, they have to bang into each other with enough force. Think of two Lego pieces. Even if you line them up perfectly, if you don't push them together, they don't react. Well, molecule A might bump into molecule B, but it doesn't hit it with enough force to actually react. So the molecules have to come in contact with each other, and they have to come in contact with each other with enough energy or force to react. The third thing that holds true for a reaction to occur is they have to hit each other at the proper position. Again, think of those Lego pieces. If I take two Lego pieces, no matter how hard I push them together, if they're not lined up correctly, they're not going to go together. Well, you kind of have this little bulbous part kind of hanging out here on molecule B and this little indentation here. That's where they need to line up to react. If they hit each other in any other position, they're not going to react. So these are the three conditions that hold true in order for two molecules when they are in solution for them to actually react with each other. Now there's three things that we can do that can speed up reactions. One of them is we can affect the temperature. Another one is we can affect the concentration. And then the third one is we can add in a catalyst. So let's take a look at these three things that we can do to help speed up the rate of a reaction and see how each one of these situations, temperature, concentration, and catalyst, how they can affect or speed up the rate of a reaction. So the first thing that we'll take a look at it as is temperature. So if I draw a little chart here and I put the reaction rate on the x-axis and then temperature on the y-axis, as temperature increases, the rate of the reaction also increases. So a way that we could show that is as temperature goes up, the reaction rate also goes up. This is a direct relationship. And the reason why is as you increase the temperature of the solution, it adds energy to each molecule. So the molecules start moving around faster. Well, if the molecules move around faster, that means they're going to bang into each other more often. And every time they bang into each other, there's a chance that they're going to react. So temperature affects the contact, has the molecules coming into contact with each other more often. And since the molecules are moving faster, they hit each other with more energy. So the temperature also helps with making sure the molecules run into each other with enough energy to react. So that's how temperature can increase the rate or the speed of a reaction. The next condition that we can take a look at is concentration. And concentration is just how much of the reactants there are in the solution. So again, if we draw a little chart, we have the rate or the speed of the reaction. And then this is just the symbol for concentration. As the concentration of the reactants go up, the rate or the speed of the reaction also goes up. So as the concentration increases, the reaction rate also increases. So when both of them go up together, that's called a direct relationship. So temperature and concentration have a direct relationship with the rate of the reaction. So think of it as you have the same size beaker, but now you have twice as many molecules floating around in the beaker. Well, if there's twice as many molecules, they're going to bump into each other more often. Just think of a room and you have 10 people blindfolded in the room and you have them walk around until they bump into each other. But now double the amount of people in the room. They're going to bump into each other twice as often. So what increasing the concentration does is it increases the chance of contact. So concentration increases the chance of the molecules bumping into each other. It doesn't do anything with the energy, but at least they hit each other more often. So that's how increasing the concentration will affect the rate or the speed of the reaction. Now, the last thing that can affect the rate or speed of a reaction is a catalyst. A catalyst is another chemical compound that speeds up the reaction, but it in itself is not consumed or taken up in the reaction. So now let's say we have our beaker there with our component A and component B. And now let's say we add a catalyst in there. And I'm going to make the catalyst a little smiley face because he likes to help people. And the catalyst, what he'll do is he kind of grabs a hold of the one molecule. That's the catalyst's hand there. And then his other hand, come over and grab the other molecule. And then once he grabs the two molecules, he kind of moves them together and he makes sure that when the molecules come in contact with each other, they always hit each other at the exact proper angle to react. So what catalysts do is they help with this third thing here. So a catalyst will make sure that the molecules always hit each other at the correct position. Now, catalysts are really powerful because you can have just a few catalyst molecules in here. And once this catalyst gets the molecule A and B to react, it lets them go, and then it goes off and helps two other molecules react. And then it lets them go and goes off and helps two other molecules react. So that's what we mean by the catalyst isn't used up in the reaction. It can help the reaction occur hundreds of times, hundreds of different molecules to react in one reaction container. So if you have a catalyst, yes, the reaction rate will increase. And if you don't have a catalyst, the reaction rate will just kind of stay the same. So hopefully you can kind of see how temperature has a direct relationship with the reaction rate. Temperature goes up, reaction rate goes up. Same thing with concentration. And if you have a catalyst, it will make the reaction go faster. And if you don't have a catalyst, it really doesn't do anything to the reaction. And over here, you can see exactly how these three components make the reaction rate increase. All right, that's it for this video. I hope you learned something, and I'll see you for the next lesson.